Good afternoon. My name is Abdullah Al-Ibrahim, and I am in the beginning mechanical engineering student from King Fahd University of Petroleum and Metals. Today, I'm going to present the casing wear mechanisms under combined rotation and translation. Okay, our objective is to study the casing wear under the rotation and translation and compare the effect under rotation only, and investigate the different type of wear mechanism developed under different parameters and determine the dominant wear mechanism. So before we start, we take our previous work. Beats 1986 discovered the main mechanism present in casing wear. Zag 2016 found that adhesive wear and abrasive wear for two dominant categories of wear mechanisms and the rotation speed and contact load. Osman 2022 results show increasing the RPM results in absence of adhesive wear. So in the introduction, as we know, as the drilling process, it has to be in an inclined way. So our issue is when we have a contact between the casing and the tool joint, and this contact will cause wear for the casing of the well. So in these two types that we are going to study it and have different parameters and see the test. For our test, we have took a lathe machine and modified the lathe machine by inserting two stepper motors with a coupled gearbox to control the contact load and the sliding motion, as we can see here. And we have inserted also a tool joint from the field, okay? And we have a casing which has been cut by 60 degrees and installed on a casing support and holder on a dynamometer so we can calculate all of the forces. In this figure, you can see our machine. This is the figure has been taken after testing directly, okay? And for our experiment parameters, we have three types of casing material, which is P110 and L80 and SM2535. And for the contact load, we have used two contact load, which is 1000 Newton and 1400 Newton. And we use a penetration rate of 0 and 2.5 millimeters per second and a rotation speed of 115 and a lubricant oil-based. Okay. For the hardness, for the P110, we have obtained the hardness by using a hardness machine to find it. And here you can see the result. And here we have the tested sample. As I mentioned before, that the samples has been, we tested the sample of the casing. For the three materials, we can see here how is the samples affected by the wear and how it's been affected in all of the three samples. And for this to measure the wear mechanisms, we have used the SEM and the digital microscope. So for our results, the estimated wear volume for different parameters, we have tested 12 samples, okay, with the different with 3 different grades and 2 contact load for each grade, and with penetration rate and without a penetration rate. And we have obtained the estimated volume, which will be explained in more detail with my colleague, Saud. And to better show of the estimated wear volume, we can see here this graph. It's going to show you the wear volume, where we found the SM2535 has the highest wear volume comparing to the 3 others. And all of the other P110 and L80 has lower. And here the blue one has 1000 Newton, and the brown, the gray is 1400. Here, when we add the penetration rate, we'll see the difference, how it's changed from before. We have the SM still the highest, but L80 has increased, and all of them, they have higher wear volume. So we can see here the L80 and SM has to get closer to each other. Okay, while P110 just increased, just not like them. Okay, for the microscope image, okay, we can see here the SM image of sample 1 with the following parameters, which is 115 RPM in oil-based and 1400 Newton and the material is P110. We can see here before adding the penetration rate, this figure is oriented 90 degree, okay? So we can see here, we have the abrasive wear, it can be shown here, okay? Comparing with when we add the penetration rate, we can see that the adhesive has increased and have a deep groove, okay? The adhesive here, we found it in many locations in the sample, but after adding the penetration rate, there is no sign of adhesive. And the solid particles are present, and the solid particles are from the lubricants. So we go here for digital microscope image for the sample 39 with the following parameters: 115 RPM in oil base and 1,400 Newton, and the material is SM2535. We can find here, we found the delamination, and there is an abrasive wear on all of the sample. This is without an penetration rate. When we add the penetration rate, there is a new something that has been found. Everything looks similar, just not the same. We found here we have a perpendicular abrasive wear, which is explained by the sliding motion, because it's having it this way, so it has effect on the casing also. So it's two direction effects on it. So that's what has been observed. Okay, for the observations, okay, we took the materials which has tested by 1,400 Newton, and we have put a scale from 0 to 3, just to what have we observed. For the S1, which is the material P110, we see here in the beginning we didn't saw a lot of abrasive wear. No, it was less, but the adhesive was high. After we add the penetration rate, the adhesive disappeared. We didn't find any adhesive, and the abrasive has increased, and the solid particles also increased. In S19, the sample, we saw the abrasive in both, where we don't have a penetration rate and when we have a penetration rate, okay, and the adhesive had decreases. And there is something has observed also the delamination. For sample 37, we see that it has a different behavior, and everything it has a different behavior. So we can see here the adhesive has disappeared, but also the abrasive has decreases, and this is something we noticed. Okay, in conclusion, under the combined sliding and rotation, the penetration, the presence of adhesive and delamination wear mechanism will decrease also, and the dominant wear mechanism, which has been observed, is the abrasive wear for all of the samples. The P110 has the highest wear resistor compared to L80 and SM2535, and it has not shown any delamination wear in all of the sample, and this is something that we observed also. And under the combined sliding and rotation, L80 and SM25 have close wear volume. And we have assumed this happened before because there's a floating of the material that happened during the testing. Since the sample has small width comparing to the reality, so this could be a factor. And thank you for your attention. And now, if anybody has a question.